Hi, scientists. So today we're going to be understanding a little bit more how the elements work in the periodic table and how they are related, how atoms work as well, as far as number of electrons, protons, neutrons, and how to find that information just by looking at one element at a periodic table or at the whole periodic table as a whole. So if you look at your page 20 IP, you should have an example of oxygen. Okay, the oxygen is an element that's located on the second row of the periodic table. Um, the atomic number is on the top, which equals 8. So the number up top in the periodic table usually equals the atomic number. The symbol is O for oxygen. Keep in mind that it doesn't always mean that the symbol is going to be the first letter of that element's name. Usually on the periodic tables, you also find the names for each element. And at the bottom, usually you find average atomic mass. Keep in mind that this is average, which means that it's averaging the mass, the atomic mass of all the oxygen isotopes we have on Earth, in our planet. So it's only an average. The best way to do this is to always round up the number to the closest whole number without decimal points. In the atomic number, that's going to equal the number of protons. Okay, that's the identity of the atom. Okay, so carbon elements always going to have 6 protons. Pretend that the proton is your lunch number. Okay, if you change your lunch number, it's no longer your lunch number, it's someone else's lunch number, so it's a different lunch number. Same thing with atoms, okay? If we change the number of protons, it becomes something else. So if you look at the periodic table and we look at the proton numbers, they are different, okay? Each different element has a different number. Keep in mind that it follows an order. It goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it follows an order. By changing the number of protons, you're going to change the element completely. So if we have an oxygen element of oxygen with 8 protons, and we change the number of protons, it becomes a nitrogen. If you add 1 proton, it becomes fluorine. So the number of proton is the identity, is the lunch number of each element. The number of neutrons, it can be found by using the atomic mass, which is on the bottom of the element symbol. So both protons and neutrons are found in the nucleus. So by knowing the number of protons, which is 6, you subtract 12 from 6, and you find the number of neutrons in the nucleus. And that's what gives the mass, the weight of the atom. So that's why it's called the atomic mass. So let's skip this one. Let's look at protons first. You find the number of protons by looking at the atomic number. So hydrogen has 1 proton because the atomic number is 1. So if you were to look at copper or vanadium, the number of protons is going to equal the atomic number. Vanadium is going to have 23, copper is going to have 29 protons, arsenic is going to have 33 protons, and platinum is going to have 78 protons. Electrons equals the number of protons in a neutral atom. All the atoms of the periodic table are neutral. If they haven't lost any electrons. So the number of electrons is going to equal the number of protons always. So if there is 1 proton on hydrogen, it's going to have 1 electron in hydrogen. So the number of electrons in vanadium is going to be 23, same as protons. Number of electrons in copper is 29, arsenic is 33, platinum is 78. So the same number of electrons is the same number of protons. Neutrons, you're going to have to do some calculations to find the number of neutrons. It equals the atomic mass minus the number of protons. Okay, so the atomic mass over here is 1.008. We're going to round this up to 1, and then we're going to subtract from the atomic mass, or the atomic mass minus the number of the atomic number, and that equals 0. Okay, so atomic mass number 1 minus the number of protons, or the atomic number, and that equals 0. So hydrogen does not have any neutrons. Okay, but in this case of here of carbon has an atomic mass of 12. You subtract that from the atomic number, which is 6. You get a total of 6 neutrons. If you add protons and neutrons together, 6 protons plus 6 neutrons average, you get 12, and that's the atomic mass. As you can see here, we broke it down for you by doing the number of protons plus the number of neutrons equals 12. Ooh. So the mass, it's always going to be a combination of both protons and neutrons. Please remember that's just the average of the mass of protons and neutrons, and that's going to change. The number of neutrons is going to change, and we're going to learn that later. So let's look, for example, at copper, which is 63.5. We're going to round this up to 64. So we're going to do the number of neutrons, which is going to be 64 minus 29, and that's going to be 35 neutrons, 29 protons, and 29 electrons.